In this module, we'll cover how you can model cooling circuits. The goal of this module will be to learn techniques to model your cooling components. Why? Because cooling channels need to be modeled accurately. I'll cover some mold features that can be modeled. Circuits, or also cooling lines, are required for a cooling analysis. Most of the heat transfer happens between the part and these circuits. Some property types that you can have access to will be channels, which are basically your cooling lines, hoses, baffles, and bubblers. So now to cover the length of your cooling channels. Increasing the length of a cooling line increases the surface area available for heat transfer. Therefore, if we look at this image, solution B is better than solution A. However, solution B is quite a bit longer. So, this can cause problems such as increased pressure drop or an excessive temperature rise. To avoid problems in long circuits, they should be broken into shorter circuits, as shown in solution C. There are two types of cooling circuit configurations. That's a series and a parallel. So series circuits have some advantages. There's a uniform flow rate and uniform heat extraction. The main problem with them is that you have a higher pressure drop because the cooling circuit line is quite long. Parallel circuits. Some of the advantages are that they're best used around inserts. They have high volume at low pressures and a low pressure drop. But they also have many disadvantages. You have a non-uniform flow rate in the branches, non-uniform pressure drops, lower branch efficiency, as well as they're prone to what we call fouling. So there may be cases where you'd like to use a baffle or a bubbler. We can model those. In most cases, they're used in areas that cannot be cooled effectively by normal cooling lines. They're used to resolve heat concentration and problems in narrow, deep geometries, so maybe in an insert or in a deep core. They achieve a high cooling efficiency caused by a turbulent flow. So a typical modeling workflow for a cooling analysis will be to open your project and place your injection cone on the part, and of course make sure it's properly oriented. Then you'll want to specify a single cavity or multi-cavity mold type. We don't support part only here. Set up your part layout. Set the defaults for the runners and cooling system if you wish. Specify the mold properties. Create your runners, whether it's manual or automatic. And then lastly, you'll create or import your cooling circuits. When modeling cooling lines, there is logic involved, like with many of the other tools that we've looked at so far. So, icons are only enabled when the prerequisite steps have been completed or accomplished. So with runner modeling, you would select your mold type, place your injection cones, set your parting plane, specify your mold properties, and then we get into our cooling modeling. You have to have at least a gate modeled. Then you'll create a cooling plane if you're creating this manually, or you can use the cooling system wizard to create your cooling system for you. You can see that when creating cooling circuits, there are a unique set of tools that are very similar to what we may have used to model our feed system in the previous modules. So when modeling cooling channels, there is a wizard available. This will automatically generate your cooling channels for you based off some simple inputs. In this menu for the wizard, you can see you can access the property of the channels from this dialog as well by simply clicking on that icon to the right of the channel dialog box. You can also specify a channel layout and distribution in here. So you can see the number of channels we're specifying. You could specify the distance between channels or just offset them from the part's boundary. There are several options here. Now, you can see here that there are some cooling channels as well as hoses, which are those gray features. What's a cooling channel and what's a hose is largely dependent on the mold size of the mold block you created. So, as I mentioned before, you need to make sure that your mold block is large enough to contain everything you need. These hoses are great and they're not breaks in your cooling channel, but hoses are simply factored in to the pressure calculations. So they do not factor or influence the heat transfer at all out of this mold. So when you're modeling your cooling system, you may create what we call a cooling plane, which is really just a modeling plane that allows you to sketch your cooling circuits on. There is a dialog box available to create, edit, as well as rename these planes for your cooling channel modeling. Just keep in mind that you can only create these parallel to the XY planes. So if for some reason you have cooling channels that are running along other planes, then you may need to get a little creative using some of our tools. So once you have your modeling planes specified, you may want to manually start to create your cooling channels. So you can access this dialog box from your ribbon and create cooling channel. You'll have to manually set your start and end points for that channel segment, just like you did when building your different segments in a feed system. There are also similar methods of connection between channel segments. So you have options to snap to the channel, and you have an option to automatically connect to the next channel, so basically to daisy chain these together. There's also some modeling grid settings, and you have access to snap tools when you're modeling. So in this case, you can see these little boxes popping up when you hover over the end of a channel. That'll let you know if you're connecting to the channel, to the grid, or somewhere else. So some of the snap tool indicators that we mentioned previously will be shown in a little more detail here on this slide. So some start point indicators we have here is when you pick that first point, if you have a vertical line, that means your first point you're selecting on the modeling grid. If you see the second image when you hover over a feature, that means you're actually going to connect it to the end of an existing channel. And the third one, final one, is the center intersection point. If you see that when you're hovering and you click on it, then you're going to start your channel at the center of an existing channel. And that'll be your starting point in that case. Now when you select your endpoint, or the second selection when creating your channel, you could have several more indicators here. So if you see a vertical line, that means that your line is parallel to the y-axis. If it's horizontal, that means it's parallel to the x-axis. Now remember, you're modeling on the xy plane, so there's no z here. The end intersection point is much like we saw in the previous screen. That means you're terminating your channel at the end of another channel. If you see the center intersection point, that means you're terminating your channel at the center of another cooling channel. If you see a rotation angle, that means that you're placing your second point at a 45 degrees in relation to your XY axis. Now if you'd like to create a bubbler or baffle, that's pretty simple as well. You create these manually, they're not accessible within the wizard. So first, you want to access the properties from this dialog box. Then, you can snap to any location along your cooling channel. And then you'll specify your start and end point. And that's it. So once you have your cooling circuit model, you'll want to set a coolant inlet. You can access this in the ribbon with the rest of the cooling tools, and what you'll do is you'll need to set an inlet point, so you click on the end of your channel somewhere so it has a starting point. You'll pick a coolant type. Is it water, ethylene glycol, or some oil mixture? Then you'll pick a flow rate and the temperature for your coolant. So let's say you model your cooling system, and now you want to move one of the channels for some reason. You can do this. There's a move channel tool, and what you would do is just click that tool, and then you grab the intersection at one of your channels and you move it. So you can either drag it like that, or you can actually specify coordinates if you wish. The one thing to note is the connection will be maintained when moving this. So if that channel is connected to another channel, or a bubbler, a baffle, or a hose, then that connection will be maintained. You're not going to break your circuit by moving it. It's also good to note that moving bubblers and baffles is also optional. So much like when we covered modeling feed system, you can also import cooling circuits as IGES, UDM, or .sty file formats. This can be very useful if you have a complex cooling circuit layout. You can model it within your CAD system as IGES curves, and then simply bring it into our software to be a cooling circuit. One possible problem with importing IGES curves as your cooling circuit is that you'll want to make sure these curves are all connected. You don't want any gaps in between curves. So before you bring it in from your CAD system, maybe zoom in, take a look, and make sure that they're connected. Because if they're not, when you bring them into our software as cooling lines, those circuits are going to be broken at those points. Long cooling circuit lines can cause problems such as assuming pressure drop and temperature rise were not an issue. Which layout would be more efficient in removing heat? The following image is an example of what type of cooling circuit layout. Cooling channels can be created by using which of the following methods in Moldflow Advisor. Connections will not be maintained when moving the end of a channel connected to another channel, bubbler, baffle, or hose. True or false? Now that you've had a chance to view this presentation, please try this exercise to further enhance your skills. For additional information on how to access this exercise, please refer to the introduction video. Thank you.